So ये cracking of long chain hydrocarbons, ठीक है? Large molecules को you're going to break it into small molecules. So you use pumice or zeolite, ठीक है? That's used as a catalyst. That's so for catalytic cracking. तो वो जो large molecule है ना, this large molecule over here, ठीक है? that large molecule, और इसको शेड कर लेते हैं, ठीक है? That large molecule which is not very useful. So this large molecule gets broken down into small pieces. So the pumice or zeolite, ठीक है? Remember, SiO2 is basically just sand. Any clay, that's SiO2. And it will by default have Al2O3 in it as well. There's a thing called pumice. It's a type of rock which is ये बल्कि घरों में होता है, ठीक है? You might have in your homes as well, ठीक है? It's a type of rock. ये पैरों के लिए इस्तेमाल होता है, ठीक है? Washrooms वगैरह के अंदर you have this to remove excess skin. But anyways, it's a rock that's got sand and silica and a lot of Al2O3 in it as well. Plus there's इसकी एक और version, there's another type of rock which is a zeolite, ठीक है? That is also used because that's also it also has a very high quantity of Al2O3 and SiO2 in it. तो मतलब इस तरह छोटे-छोटे pieces के अंदर it's going to be used. So that's another rock. It's very similar to pumice. So pumice and zeolites are used. And what you get is you get small molecules as a result. Small molecules which are usually alkanes and alkenes. Or plus एक byproduct होता है which is small molecules plus you also get hydrogen gas. ठीक है? So you also get hydrogen gas out of it. These small molecules are obviously more useful. Why are they more useful? Because they tend to have low melting and boiling points. Because obviously they have small molecules, they have less. So they have less van der Waals. Or they've got small molecules, less van der Waals forces, and the other thing is they're going to be less viscous. They will flow easily. Just like petrol hota hai na, they're going to flow easily through pipes, so easy to transport, and they're going to be very flammable as well. So they're going to be very flammable as well. So as a cracking में होता है, cracking के अंदर any number of products could be possible, a variety of products could be possible. So if I have let's say I've got a big chain, ठीक है? और ये बाकी ना, this is all so this is all H atoms. तो जैसे ये सारे H atoms है, H. Now the molecule can literally break. A molecule could literally break at any point. ठीक है? So it might break over here, and that will result in the formation of two smaller molecules. It's always going to be a smaller molecule. एक ये हो गया. and one of them is this one. Now to complete the bonds, a double bond is going to be produced. Okay, so there's going to be a double bond that's going to be produced here and a double bond produced over here. So they would have to let go of one of the H atoms because bonds are the organ. Okay, so while the double bond is getting produced, अच्छा यहाँ पे भी एक H atom, so the H atoms will get together to form. It's going to form H2 gas molecules. ठीक है, it's going to form H2 gas molecules. So you clear है you can crack it at any point and you'll get a mixture of alkanes, alkenes, and a lot of different products. ठीक है? Is this clear?
Yes, sir.
Yes, sir.
अच्छा तो आपने you'll be asked to make random equations out of this. This is how many? This is 3, 4, 5, 8 है? 8 is, this is C8H12 H18 I guess. So I'm just saying if you crack C8H18, okay, you must know how to make equations out of it. Okay, so you've got C8H18. So let's say वो crack हो जाता है, it forms maybe an alkane C2H6 and maybe an alkene that has the rest of the 6 carbon atoms. So वो आपने hydrogens पूरे करने हैं, so that's 18, 6 are gone, so that's going to be 12, right? So I've got ethane and I've got hexene. ठीक है, so I've got ethane and I've got hexene. उसी तरह आप इसको कहीं और से भी क्रैक कर सकते हो. Maybe you might have a methane molecule. So एक methane आता है, I've got 7 carbon atoms. So I've got let's say C3H6. So that is an alkene. So how many carbons? That's 4. So I've got 4 carbon atoms left. So let's see what I can make out of that one. The 4 carbon atoms. So hydrogens कितने हो गए? That's 10, and I've got 8 hydrogens left. ठीक है, तो बस जो भी है ना टोटल होना चाहिए, that should be C8H18. I guess that is it? ये ठीक है ना? सही है? Is this clear?
Yes, sir.
So
Yes.
alkane and 2 alkenes. So ठीक है, that sums it up. ठीक है, so you're going to get a mixture of I mean over here you're getting a mixture of 2. और hydrogen gas तब होती है जब hydrogens पूरे ना होने. Just make sure you put in a hydrogen gas. Let's say I've got 2 alkenes as a product. So let's say I've got C3H6 and I've got C5 and H10. ठीक है, and alkene is CnH2n. So that is 8 carbon atoms and 16 hydrogens. So I still have 2 hydrogens left. So that's H2 gas. ठीक है, so it's going to be a mixture of alkane, alkenes, and so it could be, it's just random. You could get any products, just make sure there's sensible products. Like they should be smaller molecules and they should all add up to form the bigger molecule. ये clear है सारा?
जी सर.
Yes, sir.
अच्छा अब आ जाओ थोड़ा से alkenes के ऊपर. ठीक है, alkenes are going to be slightly lengthy. Alkanes में you just had basically one reaction. अच्छा alkenes अच्छा alkenes the general formula is CnH2n. ठीक है. अच्छा ये वाला alkenes. CnH2 and ठीक है, you've got a double bond. That's what an alkene is. उसकी नेमिंग वगैरह सब कुछ हमने कर लिया, ठीक है. What was the type of hybridization when alkenes? What was the type of hybridization in alkenes?
sp2.
ठीक है, sp2 होती थी, which meant के in sp2 hybridized carbon atom, both carbons were actually sp2 hybridized, ठीक है. So what would happen is that over here, in this case, the carbon was only bonded to just 3 atoms, one electron on top, one over here, one over here. So carbon would actually look something like this, ठीक है. बल्कि इसको let's make it ethene, ठीक है, just to simplify. ये वाला part खत्म कर देते हैं. So what will happen in this case is that carbon was bonded to 3 atoms, ठीक है. On one side there's an H, on the other side there's an H, and on one side you've got a carbon atom, ठीक है. The other carbon atom was exactly the same as well, that it's bonded to, on one side there was a carbon atom, or on one side there was, sorry, another hydrogen atom. तो अच्छा ये था. अच्छा ये था. Now the thing was okay, when you had I mean there was an H bonded over here, an H bonded over here, an H bonded over here, and an H that is bonded over here, ठीक है. So that's the first thing. और उसके बाद ये था कि since it is bonded this way, the carbon had an electron that was left. It had 4 electrons in its outer shell. The 4th electron was just in this orbital over here, ठीक है. It wasn't doing anything. The negative charge was all distributed in this orbital over here, and उधर भी वही था. So what they ended up doing was that they tried to gain each other's electrons, and they started overlapping above and below, and that resulted in the formation of a pi electron cloud. ठीक है, is this clear?
जी सर.
Yes, sir.
So remember this, when you have a double bond, ठीक है, whenever you have an alkene, so there's going to be a normal electron sharing that's going to happen right in the center, ठीक है, both carbons trying to pull each other's electrons, and the electrons will be right in the middle over here. The carbon and H sharing electrons over here, the carbon and H, so but one of the electrons would be overlapping above and below. That will make the double bond. So you've got a pi electron cloud. And that's a very high charge density pi electron cloud, okay? So the high charge density pi electron cloud. Now, since you've got a very high charge density pi electron cloud, what things get attracted to negative charge? Negative charge के साथ था. Like in most molecules, in most alkenes, the reaction will happen with the double bond, because things are going to be attracted to electrons. And what things get attracted to electrons? Electrophiles, they always get attracted to electrons. Electrophiles, हमने क्या कहा था? Electrophiles are substances that are attracted to electrons. They could be positively charged atoms, मतलब positively charged ions होते हैं, or anything that's got a slight positive charge. ठीक है, anything that's electron deficient, species that are electron deficient, that are in need of electrons. I mean, their outer shells are not complete, so they're attracted to electrons. So they would all be attracted to this pi electron cloud, this high charge density pi electron cloud, this region of where there's a lot of electrons present. Okay? 4 electrons being shared over here. But remember, it's not the sigma bond in the middle that's that is bonding. It's wo jo outer pi electron cloud, that's the one that's bonding to it. Is this clear?
जी sir.
It's clear. Am I clear?
Yes.
Achha, so Melena, what I'll do is I'll do the mechanism right away. Okay, so anything that needs electrons, that's an electrophile, and electrophiles will be attracted to this pi electron cloud. So the first reaction, the first one, you can remember the first reaction. All reactions are going to be known as electrophilic. Addition reactions. And basically in electrophilic addition, what goes on is that you've got a हर दफा यही होगा कि what will happen is कि there might be a molecule that's an alkene, and there might be an electrophile. Let's call that electrophile XY. So that electrophile will not get attracted to any other part. This electrophile will get attracted to this double bond. And what they'll do is they'll just get added to it. Okay, this is the only product that's going to be formed, is that the molecule will remain exactly the same. There's going to be, so the molecule remains exactly the same except for the fact कि आपका जो double bond है ना, that goes away because somebody steals those electrons. So there might be an X and there might be a Y that will be trying to gain those electrons. वो जो pi electron cloud बना हुआ है ना, somebody is going to come in and steal those electrons. और उसके अंदर कितने electrons हैं? There's one electron being shared each, right? So one atom will take one electron, the other atom will also take one electron. So that is what electrophilic addition basically is in general terms. ये clear है?
जी sir.
Yes, sir.
और इसमें ये कि the first one, that's a, so these are all electrophilic addition. So the first one is the bromination reaction. Now the bromination reaction is exactly the same. No difference. इसी को पकड़ो. ठीक है, just change XY to Br2 molecules, right? So बस वही करना है कि, so I have this thing. So I'll just change this to Br2. So I'll just change it to Br2 molecule, and the bromines, they get added to the double bond. Okay, that's bromination. The conditions for this is, first thing is it's room temperature and pressure. I mean, that means you don't need any special conditions. The bromine just gets attracted to the double bond. Br2 aqueous is used. Solvent, it's going to be, the solvent is going to be either aqueous or inert. Or inert में it's CCl. Tetrachloride, ठीक है, bromination में you use tetrachloromethane, CCl4. But you can also use Br2 aqueous as well. The other thing is that if aqueous, तो अगर तो aqueous होगा ना, तो there's a chance of this getting formed as well. Okay, you won't get just this product, you might get NaOH as well, क्योंकि aqueous के अंदर there is water. So either one of the BRs could be either one of them. They, instead of that BR, there might be an OH group that might be attached, that might be coming from तो if aqueous. ये क्लियर है?
जी सर.
इसकी क्या खास बात होती है वो लेवल्स में? Why was this reaction so important?
सर सिर्फ एडिशन रिएक्शंस में ज़्यादा इम्पोर्टेंट था.
क्यों? इसका ना इसकी इंपॉर्टेंस ये थी कि it was a test for identifying alkenes. याद है?
Yes, it
जी
was
सर.
a test for unsaturated compounds, sir.
ठीक है. So it's a test for identification of unsaturated. Anything that's got a double bond, it's going to result in a positive test. Test for identification of unsaturated compounds. And what was the test? I mean, you do this reaction, and the positive test is if you got a positive test, the result will be that the red, orange, brown bromine gets decolorized. Brown Br2 it decolorizes. ठीक है? तो ये तो clear है सारों को. This is going to be used as a test for identification. Is that clear?
जी सर.
Yes, sir.
अच्छा, अब इस पे ना एक मैकेनिज्म आ गया फिर से. क्यों होता है रिएक्शन? ठीक है, that's the question. Now, remember this applies, all electrophilic addition mechanisms will be exactly the same. So addition so now all of them will be exactly the same. So stepwise, what's going on here? What's going on here is that you had a इसको बड़ा करके शो कर देते हैं. You had an ethene का कर लेते हैं. So you had an ethene molecule, and the Br2 molecule, why was it attracted to ethene in the first place? पहले तो बताओ कि is Br2 molecule polar or non-polar? ये जो Br2
Non-polar.
ठीक है, it's non-polar. The electrons are equally distributed. The electrons are not going to one side. ठीक है, both of them are Br atoms. So both of them are pulling electrons with equal strength. तो ये जो बीच में electrons नहीं है, यहाँ पे shared electrons, ठीक है, they're being pulled by equal strength with top वाला भी और bottom वाला. So it's non-polar. तो अगर तो वो non-polar है, would it get attracted to this double bond? अभी करेगा attract कि नहीं करेगा?
अभी तो नहीं सर.
अभी नहीं करेगा क्योंकि there's a negative charge, but it doesn't really have a charge. ठीक है? So right now the bromine molecule is not attracted to the double bond. ठीक है? हुनैद clear है? अहमद clear है?
Yes, sir.
तो अभी तो there's no attraction. But what actually happens is that, for example, they end up colliding with each other. Like this Br2 molecule is heading and it's right in the direction of the double bond, right? So I told you that the double bond has a lot of negative charge. So what that negative charge over here will do is it's going to repel the electrons in this bond over here. And your electrons are going to be repelled downwards. They're going to be pushed away, right? When that happens, when this thing happens, the bottom Br becomes slightly more negative and the top Br becomes slightly more positive. Is that clear? ये चीज clear है?
Yes, sir.
Yes, sir.
So originally it wasn't really attracted to it, but now it is attracted to it because one of the Br is now positive and the other one is negative. So the positive Br is going to be attracted to the, it's going to be attracted to the electrons. ठीक है, वो जो अगर मैं इसकी उसके साथ साइड बाय साइड पिक्चर्स ड्रॉ करूँ ना, तो मैं इसको मैं उठा के ड्रॉ कर लूँ. ठीक है, तो this is what's going down. के so this is मैंने इधर कर लेते हैं. So basically what's happening is so this is what is happening. Let's go जल्दी से. ठीक है, now you have to get, remember when they ask you to draw the mechanism, you have to get every single arrow correct. बल्कि इसको नीचे कर लेते हैं. अच्छा, फिर अगला स्टेप क्या होगा कि what is going to be the next step? The next step is okay, now the Br molecule is getting attracted to it, but only one of the Br is getting attracted to it. The other one is actually getting repelled. वो जो negative वाला है, that's going to be repelled even more, and the positive one is going to be attracted even more. Is that clear?
Yes, sir.
तो होता ये है कि negative वाला जो ना अपने electrons लेके side पे हो जाता है because it's getting repelled too much. Now you're left with just, now it's no longer just negative, now it's actually fully negative because वो इलेक्ट्रॉन सारे के सारे उसके पास आ गए. ठीक है, so now it's a fully negative Br -1 ion, right? और जो top वाला है, previously it was just slightly positive, now it's like fully positive. It's like it's got +1 charge because it lost its electrons. So what will the Br +1 do? It will go with the, it will try and grab all the electrons from the electron cloud. तो उसके पास जाएगा electron cloud के जितने भी electrons थे, it's going to grab all of them and get attracted to them, and it's going to steal all those electrons from the electron cloud. तो यहाँ पे ना ये जाएगा, and where will those electrons go? Those electrons will get attracted to Br +1. So previously, and the Br is no longer +1 because it got its electrons. Is that clear?
Yes, sir.
But this
Yes, sir.
but this carbon over here is now +1. Why? Because वो जो electron cloud था, it had electrons that belonged to this carbon as well, and this Br stole all those electrons. So इसको तो electrons मिल गए and it became neutral, but the other one became positively charged because somebody stole its electrons as well. Is that clear?
Yes, sir.
तो ये आपका ना second part हो गया. ठीक है, तो next part क्या होगा? That will be, now the Br -1 comes back because now this is a carbocation. So the Br -1 comes back and that is going to be attracted to this carbon that is positively charged, and you'll eventually get your product, which is, what is going to be your product? Okay, the molecule will now have 2 Br atoms. ठीक है, this ये अपने electrons लेके पहुंच जाएगा उस तक. So this one will become, the Br positive will join with the carbon, the Br which was negative will join with the carbon that was positive. ठीक है, so you finally got your two. So you finally got your 2 Br atoms in the molecule. So is this clear? ये reaction scheme clear है?
Yes, sir.
तो पेपर में एक्चुअली ना ये ड्रॉ करना है. ठीक है, दिस इज जो नीचे वाला है, ऊपर वाला तो ज्यादा समझाने के लिए था. बल्कि नीचे मैं दोबारा उसी को draw कर लेता हूँ. Okay, but I'm not going to draw the actual three-dimensional shape, etc. I'll just draw a simple version, which is that the next step is that the double bond goes away. And why does it go away? Because one of the BRs, the positive one, stole all the electrons. And there's a BR minus one with its electrons, and those electrons, it's a carbocation, and they're going to come in and they're going to join with this. Okay, so your molecule is going to be complete then. It's going to be HH. और BR, ठीक है. तो ये आपके पास, अच्छा ये आपके पास आ गया रिएक्शन स्कीम, ठीक है. So that's going on, and that's so you got to remember this one. ठीक है, clear?
Yes.
Yes, sir.
और वो पूछेंगे electrophilic addition, bromination, make sure. So everything has to be. अच्छा इसके वो थोड़ा सा, this the first one is step 1, the second one is step 2. It's a 2-step reaction. Step 1 and then step 2. और इसमें एक और चीज है कि this is known as a carbocation intermediate. When the carbon atom gets a positive charge, that's known as a carbocation. Intermediate. ठीक है, that's what it is. तो बस बन गया ये, ठीक है, रिएक्शन हो गया, that's it. तो बाकी हम electrophilic addition of alkenes के we'll do tomorrow. Clear है?
Okay, sir.
चले, okay. Take care, Allah Hafiz.
Hafiz.
Okay, thank you, sir.